was on professional practice. Now we're recording. So our first series is on professional practice. It's a great conversation. We'll have that up on our YouTube channel shortly. And then our third and final series will be later in the summer on race and architecture on July 27th. And so that should be a really good one, and we will share out more information about that. And without further ado, I will turn it over to our moderator. Battery. All right, Anthony, I'll give you a battery, a new one momentarily.
Battery's 2.5 years old. Right.
This is two.
Okay.
2 bars.
2 bars. All right. Well, thanks for joining us. My name is Anthony Pinrini. I am a faculty at Wentworth and a practitioner at a practice called Studio Luz in Rossendale. So I'm very happy to be meeting out tonight and part of this. And I think the concept or the theme tonight is materials and making it. So thinking about this and what this means to practice, to our teaching and learning. I quickly realized that it's just an enormous range of intersections with the world at large this time. So materials and the process of making it, construction, they're cultural, they're climactic, geographic, they're ecological, they're biosystems based. They can be artistic, conceptual, full of risks and potential rewards. And so these material systems in making create very specific relationships to form and performance. And the material systems employed within the project inform our spacing, our sizing, our limits, and they're kind of a fascinating parameter for us to think about and designers to engage with. So tonight, we're going to explore this with our guests, these kinds of questions and how they approach it in their own thinking, practice, teaching, learning, and maybe think about current techniques, speculative practices as well. And we can discuss how learning through making embodies a degree of certainty and risk, carefully planned robotic execution versus kind of intuitive reactions, right? Where a designer may gain new forms of knowledge. So it's kind of with those thoughts in the air when I'm going to make an introduction to our guests. We're going to start out with Yasmin Robles, co-founder of Ultramonger, assistant professor of architecture at Harvard GSC. And Yasmin sees the Academy as an experimental platform for testing and exchanging ideas about architecture, rather than a retreat from the issues of today's political, social, and environmental context. Her teaching aims to foster curiosity and these complexities through design. And Robert Trumbore joining us, practicing artist and associate professor of architecture at Wentworth. So colleagues and we teach together. I'm very happy being here. Rob prefers to occupy the space between and identifies first and foremost as a maker. His work engages in art, architecture, and landscape through the medium of installation and emerging technologies. His work is often highly collaborative, involving several collaborators from various realms: students, artists, architects, writers, musicians, composers, you name it, right? And online, somewhere, I think, is Jeffrey Shantz.
Yes.
Hi, Jeffrey. I don't see you, but maybe you see me. Welcome, partner of E4H Environments for Health, Architecture, and visiting lecturer at Mass Art. He says he's a member of the creative class, science and technology architect, and focused in the design of lab buildings. He tries to seek out projects that are on the cutting edge of the field and create the environments that move the state of the art forward. So, as I said, Jeff will be joining us via Zoom. Those of you who are on Zoom, please enter questions in the chat as we go. Each of our guests tonight will be making a brief presentation about their work, about 10 minutes or so. And I think, fair warning, we do have a mute button over there, so just like the debates, right?
Yep.
No, we do want to keep it to a reasonable time frame, so just asking people to take about 10 minutes or so. And without further ado, we can turn this over to our guests. Yasmin, do you want to lead us off?
Hello, I'm Yasmin Robles. I have an office called Ultramodern. we're kind of based between Boston and Providence, Rhode Island. I also teach at the Harvard GSD. Thanks so much for having me. I guess when we talk about materials and making, it should be said that in my own office, we make a lot of physical models and mock-ups, and it's a really kind of important part of our process. And so I think there's this question of how do you engage, these processes also then in the academy. How does that come into the work that we do at school? I want to talk about maybe two different timescales of maybe engaging these questions. The first one is a kind of weekend materials workshop that I did this February at WashU, St. Louis. And then the second one is a kind of semester-long course on construction systems at the GSD. And I wanted to kind of compare and contrast these two approaches because I think that they just kind of engage these questions in very, very different ways. So as I mentioned, the first one was really this kind of very short, intense workshop with undergraduate students at WashU St. Louis, where students were tasked to make a big hat in teams. And they were given just two kind of soft and floppy materials, some fabric, kind of translucent fabric, and then some piano wire, and then some kind of additional clips and small things. And they kind of had to think about how could those two materials work together. And I think it's the kind of thing that's intentionally not something that is easy to predict through drawings or through digital models. It's something that the students have to kind of get their hands on the materials and just start to kind of experiment. And I think the intention is that the material and the way that the fabrication occurs really kind of starts to speak back to the designers. So taking inspiration from things such as these structures, which are fabric and glass fibers, how could these two materials kind of work together structurally to create kind of form and space? The shred's a lot of fun. It's an annual shred that they do at WashU, and the students are working in teams. They're fueled by pizza over the course of several days, and they kind of just work intensely of kind of experimenting and playing with materials to develop something to be kind of complete by the end of the weekend. And it was really fun to see that the students, I think a lot of the trajectories, started out with very specific intention through sketches and very specific concept, and very quickly realized that those initial ideas had to be revised as they were kind of experimenting with the materials. So students start to think about kind of transformable structures, structures that kind of really move with the body, questions of color, and maybe even kind of questions of identity. Also, interestingly, came into the conversation very quickly. But also, it's for architecture students. These are not buildings that they're designing, but they're these kind of smallish objects, but they hold lessons, I think, for maybe translating into how we work with materials in buildings. So how do you think about structure in its relationship to skin or panelization, or just even the kind of process of going from 2D to 3D, are kind of lessons that are learned maybe that we can shred such as this. And then the second, maybe very different approach to thinking about materials and making is in the context, let's say, of a lecture course at the GSD, which is focused on construction systems. And so this is a semester-long course. It inherently, and I should mention, I started teaching this course and I had developed the syllabus during COVID. So inevitably, it's something that started out, online, and kind of access to making was simply something that wasn't quite possible at that moment. So how do we think about these very same issues in that context? And I think what's interesting is that even though it's less maybe hands-on, I think that there are all kinds of other questions that start to come up when students are thinking about materials and material systems at the building scale. Questions of just how does design kind of interface with kind of systems of assembly, questions of design, question of culture. We tried to look at both kind of standard systems, but also kind of new technologies such as mass timber, Grand Earth. But I think what's really important is that when we look at these different material systems, is to kind of tease out all of the different entanglements that they might mean when we build with them. So where do these materials come from and what are the kind of communities that are impacted, where they're sourced, but also who makes these buildings, and how does that really kind of impact the way that the building comes together and the way that we kind of experience these projects at the end. I think what's also been really interesting is kind of trying to kind of reconsider what are the pieces of architecture that we look at in a class like this. And I think it's a tricky challenge because much of the kind of detailed documentations of buildings is, heavily European or heavily North American. How do we kind of expand our understanding of all these other amazing traditions that I think we really don't understand very well and that we've kind of lost in the process of modernization. So we also try to do some research into construction techniques such as this one. This one's in the Himalayas, called Kathkuni, which is a kind of interesting combination of timber and stone construction, which actually creates these structures that are surprising to us, kind of earthquake resistant, actually relative to kind of reinforced concrete construction. So I think there's a lot of work to be done in a class like this to kind of rethink some of the kind of standard systems that we typically look at. But it's more research based, so students are looking at trying to understand just how a building comes together. What are the different pieces involved, but also who's making these things, and then trying to really draw through them and kind of embed their representations with this kind of information. How do assemblies come together? So these are some examples of the student work from that class for their case studies. The other thing they do, which I think is more typical of a class like this, is to kind of build these almost like little mock-up models of their case studies to kind of understand in 3 dimensions, how do these assemblies come together? How do materials come together? How is that integrated with HVAC, for example? And how do all these questions of making relate back to the big kind of design ideas and intentions that these buildings have? And even though I would say that these aren't like full-scale, obviously not full-scale mock-ups of the buildings, there is an interesting thing that can happen where some of the processes that the students use for making the models are, in a way, a role-playing, let's say, some of the processes that were used in making the buildings. So this, for example, was an interesting one where students were kind of salvaging materials from their other students' models in the studios that had been discarded and reusing them to kind of construct their own mock-up of this project. But I think there's something about the physical model that becomes really important because they're able to kind of compare, right? To kind of understand what are the things that are consistent between projects and what are the things that are actually quite special and unique about these constructions. But I think that can only go so far. So the other thing that they do is that they have to kind of talk and write about these things and to kind of really engage a conversation to kind of contextualize these projects and to, I guess fold them into these kind of larger cultural questions in which construction and making always tends to happen. So that's it for me. I'm happy to hand it off to the next one.
Okay, hi everybody. My name is Rob Trembore, teacher at Wentworth Institute of Technology. I've been teaching there for about 15 years. Let's see. So I want to contextualize a little bit where I come from on this topic and look a little bit at history just for a quick second. So I start with this image. It's the Kazan machine. I'm not sure if anyone is familiar with this piece of equipment. It was made by the Eames Partnership back in the day in the early 40s. And it was a tool for them to experiment with bent plywood. And I show this for a couple reasons. One, I just think it's this amazing thing, and it reminds me a lot of what I always hope to see in studios and outside of shops and in school. But the second reason, I guess, for me is that it's inspirational in the sense that it sort of embodies this interdisciplinary approach to practice and to art and to teaching. So it sort of, for me, it's this thing that represents the beginning of something, like sort of curiosity about materials and processes. And then to just further that a little bit with the aims in mind, we can sort of look at the 21st century, going back to the year 2000, just a little bit before that, when PS1 started their Young Architects program. And part of that, along with a lot of other forces, really sort of provoked a lot of interest in making and working at full scale. So this is just a diagram that sort of looks at some projects that happened from the beginning of the 2000s. And you can, I guess, sort of make a point that there's a few different reasons why this happened. There's the proliferation of fabrication tools, digital fabrication tools around this time. Computation became a big thing at this time also. And lastly, there's sort of a big surge in material investigations and curiosities around materials. And the image on the left is Dunescape by Shop Architects, which was really the first Young Architects project built in this program in 2000. And then the image on the right is their Brooklyn project for the Barclays Center. And I show these two because I think you can make the connection between an idea of trying to find complexity through a system early on with 2x, and then looking at how project manifests in a very much more complicated steel project for the Barclays Center, and see how that process spurred an approach to practice into making. And I'm just going to read one quick thing from my syllabus. Don't worry, it's not attendance policies or anything. Situated between the scales of furniture and architecture, in schools we often leverage what has come to be known as the research pavilion. Unlike its sibling, the installation which endeavors to wonder, provoke, and question, the research pavilion demands to know. It aims to prove and anticipates an unpredictable future. It strives to be the lightest, the strongest, the most portable, the most geometrically complex, the fastest, the most effortlessly deployed, the most efficient, the least expensive, the most sustainable with the ecological footprint of a honeybee, and of course, always without question, it promises to be the first of its kind. The research pavilion is, in short, impossible, but we do it anyway, which has always been sort of a curiosity. So getting to teaching specifically, I've taught a number of studios at the senior level and occasionally at the graduate level. So they're a little bit more advanced studios, and they're sometimes option studios or fit within our concentration groups or whatnot. So I just want to talk quickly about 3 different studios. And what sort of brings them all together is the idea that we're running the projects in reverse. In other words, starting with the material as a resource for inspiration and understanding how that could lead to form finding and other kinds of ideas. So the first one I'm going to talk about, you can see Mark Mulligan here, enthusiastic critic, is some work that we've done with carbon fiber, both at Wentworth and also at the Autodesk Build Space in Boston. So carbon fiber, if you don't know it, is a pre-impregnated fiber material. It relies entirely on tension. So the idea of building jigs and assemblies and systems for creating tension to arrive at a form that's structural is really sort of key to the process. So we look for logics within that system, how to achieve structure, lightness. There's all kinds of interesting aspects to it. So the students really begin with exploring the material itself by hand. All of this work is done by hand. So they both have to think about the system of the jig assembly and how that works in conjunction with the material itself. And then looking at how you can begin to develop a strategy for creating structure and space movement and so on. These are all, I should also say students work always in teams because of the type of work that we do. So this particular group, student arrived at a form, which you can see in the sort of upper left here, which was an idea about a jig system that could be very flexible and adapt to a range of forms. And then in conjunction with the kind of rib, not the rib, the tube piece is the idea of the joint and how they connect. So that developed into an idea about a tree structure, a branching system that could then be adapted to derive various forms. You can see the jig on the upper left that was further developed, and the system behind that. And we arrived at a sort of pavilion scale project, and then lo and behold, COVID happened, and the world went sideways. So everyone went home. So we worked from home after that. So we didn't get to, we sort of got to the prototyping stage of this, but super interesting project. This was working with plywood, which is a kind of different process, of course, which is more of a subtractive process. And this was working in conjunction with the Boston-based nonprofit Digital Ready. So students were tasked with creating a makerspace, a learning space. We call them learning pods that could be put across the city. But the students started with joinery and trying to understand how to work with a two-dimensional sheet good material. So these are just some images of the progression of a very, very early idea into a final form. The students had to take that systems approach and look at the flexibility, adaptability, and start to test how it would play out in a system. The image on the left is just one adaptation of this sort of component-based system. While we were doing that, we were also working with who we considered the client at the time, which were the students in Digital Ready in year 13, to understand from their point of view how they could imagine a learning space with this kind of system. And I should say that there were 3 different teams happening simultaneously, looking at different approaches. And then how the system gets deployed into a component-based system that's very flexible. And these were the prototypes that we landed on at the end of the semester. Full scale, fully detailed, really focusing primarily on the structure. And then lastly is work more recently being looked at, which is using clay and using an extrusion process along in conjunction with a robot. So a lot of this work was done both at the time that we're developing tooling for the robot to be able to produce the clay extrusion alongside testing it at a studio scale. This particular project looked at just a very simple idea of looking at pattern making and depth, and looking how a two-dimensional extrusion process, very much like a 3D printer, but using clay attached to a robot, could create a system for screening. So most of the application on these projects are oftentimes around sun and using it as a screening system. This project looked at taking a typical brick scale piece, but twisting it. So rotating the 2 sides, the 2 ends, and seeing what that could provide in terms of a different approach to shading. And this involved a lot of more complex robotics, including 6-axis printing, which was really interesting. And then the application up on the upper right, close to Anthony's, was for a thermal pool in Iceland. So that was the architectural application. And then a last example of a group of students who were interested in the sort of language of simple geometries, but beginning to rotate them and manipulate them. One of the big advantages of of clay is that you can really be very, very custom with the way that you're working. So you can carefully deposit the clay that you want to and reduce it where you don't need it and so on. So there's an interesting approach to additive processes like this. And then the last image is this sort of hypostyle hall kind of project where they developed a structural system around these very large printed pieces. And the speculation on this was that it would be printed with concrete off-site and then brought and installed on site. And I think that's where I'm going to end it. Yeah. Okay, Jeffrey Shantz will be joining us online.
Okay. Can you guys hear me?
Yeah.
Sorry, my wife just came in to share a video call. I've been isolating for COVID for the last 3 or 4 days, so that's why I'm not there tonight. So a little bit of background on Massmaker. Massmaker is kind of the product of sort of 3 confluent experiences that I've had in my career. The first one was I moved back to Boston in 2015. It was my attempt to basically get off of airplanes. Because I build science buildings for a living, I decided I should no longer live in places that don't build science buildings, otherwise known as Florida, and move someplace where science buildings are built that I can then drive to and not have to get on airplanes for. So I picked up my practice and I moved back here. When I moved back, I got in touch with Meg Hickey, who was one of my mentors when I was an undergraduate at MassArt, and she asked if I would teach a studio. And I said, that would be fine. Let me make you a proposal. So what I thought about 2 things. The first one was I had just spent about the last decade before that designing engineering schools, mostly for top 10 engineering schools. The University of Florida, Caltech, University of Maryland, University of Chicago. I did major projects for all of these places. And while I was doing them, the story that was told to me by the deans of these schools in almost every instance was the same, that they wanted to use the building as a catalyst to revise their curriculum. And I would ask them, how is it that you want to teach, the future that you're not doing today? And, they would describe to me how they want it to be hands-on, how they want it to be very material focused, less time in the classroom, less time doing math, more time making. And what I realized by the end of that conversation was what they were really telling me was they wanted the curriculum that I had at MassArt when I was there in the 1980s. What we were taught was essentially a Bauhaus curriculum where we kind of went material by material. We were taught ceramics, we were taught glass, we were taught metals, we were taught masonry, we were taught, all of these things. And so I decided that if you're going to do that, you can't really saddle these kids with the Bauhaus curriculum. You have to give them a curriculum that is relevant in an age of digital fabrication. And that's where I drew on my experience. I worked for a time, for about 8 years, I was a consultant to the Jet Propulsion Laboratories on the Mars programs. And one of the things that we did during the ramp up and the creation of the rovers was we would have to engage in quite a bit of science fiction. In other words, you would have to imagine the things that you wanted to make well ahead of the fact that the engineers would get involved. So the process that we engaged with them was we would kind of come up with these ideas. And then the question they would always ask me was, well, do you know somebody who can make that? Right? Because if you couldn't make it, it wasn't real. So I thought that if it's true that the engineering schools want to be more like the art schools, why not go back to the art school and teach them some of what the engineers know in a way that would be useful to creative types? How do I advance the slide? Oh, there you go, advance the slide. So this is really designed to kind of follow the way that innovation happens over time, because things happen generationally. You get these paradigm shifts. And really, we're kind of in this 6th wave right now, which is about mostly convergence. And in an age of convergence, what you really need is you need design methods. You need ways to think about the world. How do you combine all of these things? Because we're in an era where we can virtually engineer anything, whether it's a synthetic life form, whether it's a device, whether it's something that flies to the moon or drives by itself, we can engineer that. That is a big sea change in the way in which our students are going to get demanded on. Go next. What I was really interested in was to try to understand what the difference was between disruption and development. It's kind of easy to be a disruptor. Anybody can be a disruptor. You just have to show up with some wild, hairy idea and then convince somebody that it's worth doing. But it's not true that disruption is the same as development. What tends to happen is disruption, good ideas the foundational ideas, they tend to happen in small teams, typically 2 or 3 people at the most. But the development is done by scaling up. So when you come up with these great ideas, when you come up with these disruptive ideas, you have to keep it rather small. You have to collaborate on a very small scale. And then from there, you move it into a large scale where collaboration and interdisciplinary science and engineering and design really does matter. Go next. So, I talk about this in terms of the innovation spectrum. And if you hit return, it'll do something funny. Or maybe not. Okay, go back. I guess I took the animation out. It was going to do something great, but I took the animation out. So basically, this is the way that we saw it. We saw it that we couldn't just teach like the engineering curriculum, because when you think of what engineering is in terms of innovation, it starts with an inventor who like comes up with an idea or a material or a process, which is very different than the way the artist works. The way the artist works is the artist will see the world in a different way and kind of work backwards towards, how do I make this work? How do I bring this to life? So what we wanted to do is we wanted to find some balance between where are you an inventor, where are you an artist, and where are you an entrepreneur? And then how can we take that and teach it to students in 16 weeks? How can we develop a curriculum that could teach you how to bring an idea from its inception through its prototyping, through its marketing, and through its reality in a 16-week course? That was the challenge that we kind of laid out for ourselves. Okay, so go next. So that's where we came up with MassMaker. And it's really this idea that we are teaching kids how to create and own their own IP, how they can become their own brand, and how they can find a part in the ecosystem that is Boston in particular, because here you can do things here that you just simply can't do in other places. But it's also this idea that D school is the new E school is the new B school, right? Because the types of skills that you learn in design school, they're applicable around all of the other processes that you need to be successful. Go next. So again, this is this interdisciplinary studio. We do an immersive approach. It's entrepreneurial. We focus on making things. We also focus on design leadership and shared success. And that is because we believe that you do have to collaborate to bring things to life, and that the design process is really built around rapid prototyping and innovation. Go next. Our goals are to teach the leadership and that collaborative design to position our students in a way that they are seen with employers and potential partners and investors, as we are the people who bring the creative side of things. In other words, we're going to make cool stuff, but if you have something that you think is really cool, but it doesn't really look that great or it doesn't function that well, we're your guys. We're the ones who can make the complex beautiful. And then we brought up the idea of trying to launch our companies into Mass Challenge and with other partners. And that's how we kind of roll. Go next. We see this as a process continuum. Mass art is basically this giant makerspace. I don't know if a lot of you have been there, but we have sort of legacy maker, which is our, we have this fantastic metal shop. We have a forge, we have a foundry, we have a glory hole and a glass shop. We have a jewelry making shop. We have basically everything the traditional artist needs. And we're building up the digital components of it with things that, CNC controlled stuff, 3D printing, all the things that you would normally complement you in this sort of thing. But we see this as this kind of process continuum because we want our kids to be able to roam around the school, find the resources that they need and bring it to bear on solving the problem that they have. The other thing that we did was we standardized on using Fusion 360. And the reason why we did Fusion 360 is because A, it's easy to learn. B, all of the mesh maker and transition to digital printing is already embedded in it. And C, it's widely distributed. It's also cloud-based, so the collaboration works out really well. And when we hit COVID, 360 was really what allowed our kids to work together while they were in the studio. Go next. So our culture, we worked a lot on the culture because, like I said, it is collaborative. It's multidisciplinary. We allow any student to take it. It's undergraduates and graduate students. We have had students from fashion design, from architecture, from illustration, from art education, from metalworking, from sculpture. We've had a whole bunch of different types of people. And really what we try to do is we set this up as sort of this collider space where we use a fail faster method to work through these problems. Because the kids will come to the class with immensely creative things, but you've got to kill the bad ideas first, but you've got to teach them how to do that. So we do fail faster so that they can burn through those ideas, get that energy kind of out on the table, and then start to focus on the thing that we think will be successful. Go next. Our tools and methods. The curriculum, when I first started this out, I had no idea how to teach this. It was an experiment. For the first 3 years, I gave everybody in the class an A for participating in my experiment because I was writing the curriculum as we went along. So what we did was we modeled it on MIT's 2 classes at MIT, which is where I did my graduate work, which is the How to Make Anything class, which is the most popular one at the Institute, taught at the Media Lab. And it's kind of like 16 skills in 16 weeks. The second one was the MECI class called Product Design 2.009, which is really a product design class. We focus on the digital skills and the design studio. So we teach a kind of, it's a 2-track curriculum. On the one side, it's skills-based, right? We want to transfer those skills. We want to teach people how to do certain things. And then on the other side, it's design-based in that we teach design thinking and critical thinking. So it's on this parallel track. We focus on the access to technology so that, you know, we have all these scalable principles involved with it. And we finish in the cloud a lot of times because a lot of times we'll get the product development to a very high level, but, you know, for instance, our machines at MassArt, they don't print at very high resolution. So we'll go out to the cloud to like 3D Hubs or Xconomy or some of the other cloud-based services that print stuff. Go next. So we think of it as kind of mixed media. The way we do it is it's a thematic approach for each semester. So for instance, we pick themes for design exploration, and then we come up with several problem statements that are things that the kids might want to explore. And from there, you do project proposals. The students self-actualize as to what it is that they want to learn. So for the last semester's themes in 2021 were really about health and wellness. And so we teamed up with Mass General Hospital's Springboard Studio to do a collaboration with them because we were trying to figure out how we survive this pandemic and can we design our way out of it. Go next. And that's really where we started. We started by talking about plagues, pandemics, and paradigm shifts. And one of the things that the students don't realize, they're 19 years old, pandemics are actually quite common throughout human history. And that there's all sorts of upheaval that goes with it, and they affect all of these things. So go next. And one of the things that they affect is the design of cities. For instance, most cities in Europe got sewer systems during the bubonic plague. They didn't have germ theory. They didn't know that enterics were the reservoir for the plague, but they knew that the ethers, if they kept them below, they knew that that people would not get as sick. So that's how London and Paris got their sewer systems. So knowing that pandemics affected the design of cities, this one affected the design of cities immediately, right? The kinds of things that we had to do to transition into spaces, wearing masks, putting materials on there that wouldn't allow the microbes to grow, ventilation systems, all of the things that we needed to fix in our infrastructure. So go next. And then we went through an exercise talking about how data matters. And this is a very famous first application of public health epidemiology was in London in 1854 during the cholera outbreak. A physician named John Snow, he tracked the spread of cholera. And he determined that there was a pattern of the spread and that the primary vector were the water pump handles at public pumps in London. So he had the city of London remove the pump handles. And after the pump handles were removed, the cholera epidemic subsided. So we studied this as a means of thinking about, okay, so we got sewer systems, we got germ theory, we figured out something with pump handles. What's relevant now? What can we do now? So go next. So as it turns out, when we got to doing things with Springboard Studio, they said to us, we have a number of project proposals we would like help with that are already in process. The doctors and stuff who are doing it need somebody like your students, creative types, who can take their ideas and turn them into something real. And so we had 3 teams, 2 of which adopted projects with Springboard. The 2 projects were one that was called Flip It to Clip It, which was really a carrying device for wheelchairs. And the second one was called ThermoCloud, and I'm going to show you a little bit about ThermoCloud in a moment. But you can see here on the left, this is the device that Springboard ended up building to do rapid testing, because at the time, the nurses had to go in when they didn't know enough about the pandemic. The nurses were gowning up in complete PPE from head to toe as if they were going into a BL4 lab. So what they did was they made this walk-in booth with a 3-sided configuration where the nurse can enter from an isolated side, and around 3 sides can swab patients for COVID. So that was one of their hacks, so to speak, for the pandemic. So go next. So this is the kids kind of pitching their own proposal. They give us a problem statement. They have to do a gap analysis, say what the pain points are. We do a market analysis, we do business plans, and we do branding. Go next. So the project requirements are very simple. It needs to result in a prototype and something that demonstrates your concept. The prototyping plan needs to have a project description. It needs to say who your team is and what you're going to do. In other words, you have to organize yourself. And then you have to put a strategy together to bring it to life. That includes, how are you going to sell it? How are you going to get investors? What is it that you think you're going to do in order to get this to go forward? So for instance, in the picture that you see here, the fellow that you see sitting at the table, his name is Cedric. Cedric graduated our program and went to Cornell and is now an architect in New York. And the fellow that you see to the right is a 9-year-old who was wandering through the Autodesk build space where we were in residence in our 2nd year. And Cedric and his team had invented what is sitting in front of him, which is a device that gamifies safety for kids. And what it does is it's sort of a glove that the kids can use to kind of ping each other with an RFID device. But what it has on it was a button to tell your parents whether you were in trouble. And it was in reaction to the Parkland shooting. They wanted to find a way to make a device to keep kids in an elementary school safe. I can only imagine what it would have been like if the kids in Uvalde had this device on them when the shooter came, because they would have been able to tell people right away and not just on their cell phones, because they would have known that it would have been a trouble thing. So that's the kind of thinking that the kids were doing at the time. Go next. So the process by which we do this is the first thing you do is you pitch yourself. On a single poster, everybody has to say who you are, where you're from, what your passion is, what's your superpower, what's your kryptonite, and why are you a good team member? Because for us, having a good team is essential to solving the problem. Go next. And pitch day looks something like this. It's called draft day, and the students will get up with their posters. They'll tell each other why they're going to be a good team member, and then they break out into the corners, they form their teams, they pitch their ideas, and by the end of the day, we're off and running with the first draft of things. Go next. Then when we get to the project teams, it's a minimum of 2 people, but really I like to have them at least 3, because we want it to be a democracy, and with 2 people, it's a stalemate, so you need an odd number. Because I'm a baseball nut, we do something called a trading deadline, because if you don't have people on your team that work well together, or you want to trade off or do a different project, you have up to 3 weeks to trade people off. The only thing is you can't leave any empty slots. So if you trade somebody to another team, you have to get somebody in return. Go next. And we do stuff like pitch into Mass Challenge. This were the kids in the 2nd level studio learning from the folks at Mass Challenge about how to build that pitch deck, how to build your business case, how to really think about, if you want to start this as a company, what does that actually mean to become an entrepreneur? Next. So part of one of the things that this led to was in our 2nd semester, since we were in residence at the build space, while I was there, I met this young man who's in the lower right-hand corner. His name is Nikita, Nikita Chenyutai. Nikita is a Russian immigrant with a high school education from Irkutsk in Russia. Nikita invented that robot that you see there, that's orange. That is a R Theta Z robot that prints concrete structures. And Nikita was lucky enough to win a NASA sponsorship to bring him here to the United States. So him and his wife came over and had a $100,000 grant, and they put them here at the build space. When they got to the build space, they started prototyping some things, and I met them while we were there. And so I had been, because of my previous experience with NASA, we talked about entering the Mars X House competition because their device could very easily be put on top of a rocket and sent to Mars. So go next. And so we won it. So the team that we put together for the Mars X House competition was led by a woman named Melody Yasser. Melody was with a firm called SC Arch at the time. I believe she's with Icon now. But she was our leader in terms of the design of things. And Nikita and his wife were the technical side for the printing of it. And I helped them out with a whole bunch of different things just because of my level of experience of stuff. But what this is NASA intends to send robotic construction to Mars ahead of astronauts landing there so that there's a habitat for the astronauts to go live in when they arrive. So the idea is that the robot has to go to Mars and build this entire building all by itself. And so we won that competition with this design. So go next. And that's our team. I mean, these are the kids, and that's kind of what they do. And we we really appreciate all their efforts and all their creativity. It's just a great bunch of people. So I think that's the end of the deck. And there we go. You guys are still on mute.
Can you hear us now? Can you hear us now?
Now we can hear you. Yes, thanks.
Okay, great. I think what was kind of fascinating to see, and for me anyway, in the presentations is the scale of one material, the body, kind of ramping up and layering up to how materials begin to interact, how they become spatial constructs, to how do they end up Mars, right? I mean, we really have a pretty broad scope of exploration in this presentation. So where does one begin in this process? Right? I'd be interested to hear that kind of starting point from each of you. Where's that kind of first question? So how do you frame that first set of questions to get this going? So we can land on Mars. Yeah.
So as I showed that example of the Kazan machine, that's, I guess, for me, where I start oftentimes, which is an idea for a material. So for the Ames at that time, plywood was sort of a new thing. And the way that you could take thin sheet laminated material and start to build it up and make a sheet stock, that was kind of a new thing. So for them, they began looking at how you could create double curvature with that same technology, but creating a machine to do it in a sense. So, and then that sort of led to the work they did for developing splints and other kinds of things for military furniture. So for me, that's oftentimes where I start. So that's why when I presented, I went through these 3 different materials. Each one of them has a very different set of properties and behaviors to it. And then the understanding those behaviors allows you to then apply what you know to an architectural application in an architectural scale.
Yeah, I would agree. I think that's a really amazing place to start, because I think you often come up with these kind of unexpected discoveries of working for kind of bottom-up approach. I think maybe another way to work is to kind of start with a problem or research question, and then kind of think about what are all the possible ways that one might kind of attack that problem, or one might get interested in that problem. And so on some level, I feel like maybe you have to work, sometimes you end up having to work from both ends, right? That these somewhere you meet in the middle, and the questions change based on the tools that you're working with, and then the materials maybe also change the question that you're asking. So I don't know, I'm very interested in like the way that these things might kind of feedback to one another as well.
Yes, and we typically start, like I said, we start with the theme. We use a thematic approach to things, and we usually try to focus on the kinds of problems that would be relevant to our students. In other words, we find that I was basically terrified when I wrote the curriculum because I'd never written a curriculum before. So one of the things that was most important was to have student engagement. And what we found was that the student engagement was much higher when you kind of empowered them to start to think about things in this way. Once they do that, we start to focus on processes very quickly. And we start to focus on the processes very quickly, plus the materials, because a lot of times when people come up with stuff, it'll go in very unpredictable directions. The other part of it is understanding what skill sets are needed. So for instance, when we started teaching the class, we would have a skill set. We had a 10-week course for skill set, and I brought in my friend Peter Jurgensen, who I went to school with, who works at Lincoln Laboratories, because Peter is just a wild maker on his own right on a lot of different things. But we did things like soldering boot camp. We did things like, Python programming. Here's how you do Raspberry Pi. Here's how you do Arduino. Here's how you do subtractive manufacturing. Here's how you do additive manufacturing. Here's how you do welding, right? So it's the kind of thing where once we understood the stuff that people needed, the skill set would kind of change for that semester to be in line with the theme.
I think the other part of getting started is one thing. The other thing is the kind of wisdom in the decision-making process, right? As you go through things. If design is about kind of setting criteria for decision-making, and there's this issue of appropriateness. Like when do you use a tool, when do you use a certain material, and under what circumstances and under what context? So I'd be curious to hear how that becomes part of the mix for you.
We have another one too.
So of course, at Anthony and I, along with Laura King, another faculty member, started teaching the past couple of years, is a course for freshmen. So that course, I deal with the digital fabrication introduction to the first year students. I learned how to 3D print and how to use laser cutters. So part of that, like showing up and knowing which tool to use for what you're doing, is primarily the main task that I take on with that class. So we introduce additive manufacturing processes, 3D printers, and subtractive, which is laser cutting. So we hope at that level, we're introducing them into what the appropriate tool is for a particular job, and then how to apply it. And then hopefully when they get into upper level students, they have more of a grasp on the appropriate use of tools, or even how to hack a tool and how to do something different or unexpected as well.
I feel like constraints end up being really important in any project. So whether those constraints are kind of imposed by a project lead, by a class, or just kind of constraining yourself to working with what's at hand, I think in some ways it's critical for the way in which we make decisions in the process. And sometimes I think we do have to kind of self-impose on these constraints. So if you're working on a competition and you make it a particular goal to kind of investigate, I don't know, carbon or scale or some kind of particular constraint for yourself, I think can drive, I think, experimentation and allow you to kind of be very specific very quickly, which I don't know, I always find that very helpful.
I just respond to that really quickly? Sorry. That's a great point, because I think with constraints, when you're making something, you're always faced with constraints. So it could be, in the instance of plate printing, you're dealing with, what we have anyway, is a continuous extrusion. So there's always this moment, like, you want to turn it off, but you can't. Or you want to be able to stop it, move the arm so someone else has printed it again. So the whole outcome is shaped by constraints.
Yeah, I agree that the constraints are just as important as where you're allowed to go. I think the flip side of doing the skills side of things is to teach the design thinking and the critical thinking. So one of the things that we talk about a lot in the class is critical thinking around, who's going to use it, why are they going to use it, what is it exactly? Is this a part in somebody else's process? And then we start to talk about, the design thinking about how can we assemble it, right? One of the things that struck me as a designer in the current age, where we're going to see a lot more components of our buildings are going to be direct to digital fabrication. What does that actually mean? It means that architecture and design becomes an act of assembly at the top level where the architect lives. But the architect also needs to own, I'm making it, right? We need to own the making of those pieces, because there's going to come a day when the students I'm teaching now, when they get to be my age, are going to press a button and the structure is going to get fabricated in a mill somewhere and get shipped to the site and erected, right? Or, the door panels or the cladding panels that go onto the building, that geometry will go directly to a contractor who will fabricate it and assemble it. So we do need to know how those things work, because some of that liability, we could become manufacturers, right? So knowing what materials to use, knowing how it's assembled, knowing what those characteristics are, all very important.
Can we follow up on something?
Please, yes, I was just about to,
Oh, okay.
that was my warm-up softball questions and.
Just something both people said, pressing a button to have something fabricated. The difference between the robot making the coils and actually rolling ceramics into a coil pot, where you're not sure where you're going, but you're learning something about the material with your hands, mind and hands. So I know Jeff talks about this at Mass Art in his class, but what happens when you don't have that same relationship to material that you do in a more traditional set of ways of making? And so it's when Jeff talked about pressing the button and boom, there it is. You have some distance between that. These are not new ideas like David Pye wrote about the nature of material. There are things that I remember reading 40 years ago that are relevant to the way we think about making today. So I think it's interesting to maybe hear you guys talk a little bit about what we've given up and what we've been able to add to our process of building things, which I think everybody here cares about. That's why we're here. Yeah. Do I have a question?
All right, I'll start with an answer. So Paul, if you remember when we were at MIT, we had Project Athena, right? And in Project Athena, we were using AutoCAD version 1.0 on small PCs. And what I realized when we were doing this was that this was going to let a lot of people who were really bad designers make architecture twice as fast. The same realization comes to light in the age of digital making, is that you're now in a situation where you are absolutely correct. The distance between the making and the act of making, the designing and the act of making, the farther away that gets, the less skillful we're going to be. And that's why I think it's essential for kids to experience these things so that they know that. It's just like in the rules of war. When people had to walk up to each other and stab each other in the neck with a knife, it was a very different experience than sitting at a machine and pressing a button and having the missiles go 50 miles over the horizon, right? So that's why I think it's essential that that you kind of normalize people to these technologies and let them know what it actually means to do it this way.
interesting thing, Jeff, is that architects have always been the press the button kind of guys. You know, the profession is based on a kind of distance between the actual making of the building. We communicate ideas, we execute the work. And so in that way, I'm pretty interested in a process which already embeds that kind of disconnect, you know, from the digital to the analog, or from the computational to the physical execution. I think it's exactly in line, and perhaps it's even an asset as we try and find some relevance for these academic pursuits in the real world of practicing architecture.
It's a hard, listen, it's a hard way to go. I tell you, there's a lot of stuff to learn.
Well, and that's always frustrated me since my first day in architecture school, was that disconnect. So I think that's partly why, for me, teaching allows me to try and bridge that in different ways. But one of the reasons why I've gravitated more towards clay, say, versus carbon fiber, both are in a line and get laid down in kind of as a line does. But clay is much more visceral in terms of like how you deal with it. And it doesn't like gravity. It doesn't like, changes in air temperature and moisture levels and so on. So you can't avoid the physicality of the material, whereas carbon fiber is a little bit different. So it behaves pretty consistently. It's also kind of gnarly to touch and to handle, whereas the clay is much more responsive. And I've tried to explain so many times to students how to mix the clay for the extruder. And there's no recipe for it. It's like, oh, that feels like peanut butter. That should be good. It's kind of usually how I go at. So having that sensibility to the material is super important, even though we might be using an industrial robot to work with it.
Yeah, it's super interesting conversation. And I think, yeah, this disconnect is both a kind of amazing opportunity, but also a problem, I think, for our profession. I think, on some level, when I think about teaching materials and making, I think there is an attempt to try to develop some kind of intuitive understanding of these materials, so that when we design a building, we have a kind of intuitive understanding of structure and the way that things might behave. I think the risk with that distancing between our working from day to day and the kind of construction happening elsewhere is that we also we're just it makes less visible all of the effects that construction has, right? We don't, the greater that distance is, the greater is that distance when we kind of try to comprehend all of the effects that the construction industry will have on populations, on the environment, and things like that. So how do we, both kind of educate ourselves about these effects and try to understand them and fold them into our work in a very kind of conscientious way, but also, I guess, have some kind of experiences like what you're saying with the kind of clay that feels like peanut butter, where we have a kind of tactile relationship to the work. Is really kind of challenged today.
I want to say something about that I guess challenging when you mentioned about, it's true that we are, as architects, distanced from the product, but we haven't always been that way. I mean, back in the day, we go all the way to Egypt, right? There was an architect that was a GC. That separation actually happened when liability came into place and we started dividing labor, right? And all those laws. So that wasn't really always the case. And there are actually countries and places in which the architect still is that sort of mastermind. I mean, you can go to Japan and China, and there's a lot more about that tactile feel to the architecture. I think that, I guess here in the United States, we're more, I guess, being in Revit and all that stuff has distanced us, because I think the relationship we have with materials happened with the pencil and paper. I think there was a little more of that sort of like flavoring of the space. And then also being more involved on the site. When you're more on the site, you start getting that. And that's something that, guess what? All of our greatest architects in history became the best at the end of their life. Mies van der Rohe, Frank Lloyd Wright, they really were at the very top, and 10 years later, or probably 5 years later, they died. They didn't even see most of their work. But because that comes over time, and that separation of labor and separation of disciplines is the issue. And I think ironic that somebody mentioned Kat came along, and we make junk a lot faster. That is true. That is true. We make really bad stuff a lot faster. But you know, and I guess it's just a comment, right? And I don't even know if this is a question, but going back to what you mentioned of the feel of material, it is this relationship between craftsmanship, materiality, art, science, right? So there is this, all of these different parts of it. And I guess there's different types of architects, right? So we go to Renzo Piano is more of this structural type of architect, right? Zaha Hadid, rest in peace, was this more of like, I guess, feeling this space type of architect. So there is this relationship between all of these elements, and sometimes one is heavier than the other. Yeah, I guess that's it. But I did want to mention something else.
But if we are destined to become master integrators as
So
opposed to master builders,
project
right?
was
And
because you desire to have, so that you say, you know what, I'm going to use this. And you mentioned that, you know, the different way of how you start probably with the material. But throughout history, if we go all the way to the beginning and the Genesis, right? It was necessity that drove everything. So one thing that I try to put into when I'm teaching is reducing even the time clock. And I remember always when I went to high school, they did this United Nations sort of symposium where you had to make certain decisions within certain time. They would literally walk into the classroom and say, we have to make life and death decisions about what's going to happen in the world. And we really had to get creative because it was a necessity and a present. And I don't know how you can actually influence or infer that, or I don't know, infuse that into the process, but that has to be a must into the process. You know, we have to move to Mars. So we really need to move to Mars, and we have about 5 months to do so, right? So then you start looking into all the possibilities, into how you can resolve that. And then the materials can come and everything can come together. And you need all of the pieces on the spectrum that he showed. All of those pieces have to really master and balance each other so that we can get to a result, or existence will end as we know it, right? So
well, we have ample precedent for what it takes to, you know, rebuild with necessity. If you look at Europe after World War II, you know, part of the reason why reinforced concrete became the material of choice was because that was the industry that was left after the destruction of the war. And it was the fastest way to put up residential units. And that was great, except for, I don't know anybody in the world who raises their hand and says, I want to live in a Soviet style block, right? So the thing is that I think that the drive towards necessity is absolutely imperative. And in my mind, the necessity to become masters of the production and the integration process is the only thing that will save us from irrelevance. Because once, you know, guys, once artificial intelligence can start figuring this stuff out for you, right, you're not going to have anything to do because the AI will figure it out for you. So, you know, the way that we will remain relevant as both a profession and as people who can affect the outcomes of these things is to make sure that that human element is present at all times, and that we are the ones who are the creators. We are the ones who, you know, originate and define. Otherwise, you know, we'll get dragged into the dustbin of history.
This is very interesting, and there's a way in which I think people are thinking about technology as kind of an amplifier. And so it's like, if you have a bad idea, it amplifies a bad idea. If you have distance from your project, it amplifies that, right? If you get closer to your project, maybe it amplifies that. But I kind of have a question related to the gentleman's point about necessity being a prompt. And it's actually an original question that I had initially for Yasmin, but I think I'd like to ask all three of you. And the question occurred to me when you talked about having your students write about their investigations. So I kind of have a two-part question about that. And the more important one is, how do you have prompts for them about writing? And how do you come up with these prompts? Like what is, and then my second question is, in our profession, there's a way in which you know, we are very all from Missouri. We like to show me, right? So, you know, architecture is a lot of show and tell. And there's a way, even in this discussion, even in your presentation, where you talked about writing being very important, it's obvious to me the stuff that was made, but it's, you know, the stuff that they actually wrote was almost presented as kind of an afterthought. But in a way, I suspect, and maybe I'm wrong, that for them, that was probably the more important thing, because that's what they carry with them. And then the question is there a part of your project, and actually this is all for all of you, even with Jeff's, you know, beginning with the Superman and, you know, this is my kryptonite, I kind of like that, and this is my superpower, this is my kryptonite. Like, is there a way in which that part, right, the part that's all more even about the thought that goes into the before I make and after I make, is there a way in which that's presented? Thank you.
Thank you for that question. The writing, yeah, the writing's interesting. So what I showed, it's actually that I asked the students to have conversations about what they've done. So they're working in groups, 6 or 7 students, but then they also are expected to have a kind of conversation about the work. And I think you're right. I do think the writing is very meaningful for them because, and the kind of conversation, because it's the moment when I think they take some of the kind of technical issues they learn in that class, their, you know, the research, the precedent study, and they have to kind of make sense out of it and make it meaningful to themselves and to their own interests. And I like the conversation format because I don't want them to feel like they're writing for me, but that they're starting to have a conversation with their peers, right? I think there's a certain set of questions that these students bring to the table, which I don't want to impose, and that they are very intensely curious about. And so how do we kind of allow, how do you kind of open up a class and allow the students to bring those interests to the material, right? Like I come at the material with my own biases, with my own interests, and I think the students come at it, you know, they're different generation, they're different, come from many different contexts and have very different questions about what the relevance of all of this stuff is. So I think the conversations is an attempt to try and allow students to open up and to maybe, you know, I think maybe sometimes studio work is a little bit more personal, or they're allowed to kind of bring their own interests into the work more clearly, less so in a technical class. So how do you bridge maybe the world of the studio and where they do their own creative work, and then a more technical class like this? How do you get them to sense that the material is really for them to kind of take and work with?
I think Tim had a
Yeah, so I'm going to try to, my earlier question has been enriched by what we just talked about. I think it's very interesting that Jeff, you emphasized the theme, and then the tools and the materials solve a problem. It's back in the necessity comment. And Yasmin, you and Rob kind of are on the opposite end, which is the theme arrives late after there's some exploration of some kind. And I'm thinking about that relative to design pedagogy in a typical architecture school. And I think, Jeffrey, the problem with themes in a class based on making is that every other studio class is theme focused. And I was just thinking about that when Yasmin was explaining her project with wire and that cloth, that which is 2 materials and not 1, that deals with fundamental kind of common architectural issue, frame and cladding, right? And it provides a context to think about tectonic and syntactical issues outside of the burden of theme, which has gotten very heavy in studios. You know, my project is to solve XYZ world problem, and then I'm going to learn how cladding goes on a frame. That disconnect in design pedagogy is a little bit of a crisis right now. So I would only say that for the educators that are here who have some administrative responsibility, I'm looking at my friend at the other end of the aisle, that it's I think it's useful to think about studio-based courses that unburden the students from theme first. That's one comment. It's not a critique of your class. It seems awesome, Jeff, but I just like, I just solved the climate change and homelessness, and I have to solve getting to Mars next. And I just wonder about that. I think the other thing that this conversation is making me think of, and it was Yasmin's excellent example of that wall technology I'd never seen in the Himalayas. How badass was that? Is that, and this is back to your comment, I think we often get too touchy-feely with this discussion. And I don't take this the wrong way, but squeeze clay and pet materials and things. I think the reason, I think now that everybody's on Revit and everything's offered up, predetermined by everybody, material classes require communicating knowledge of technique, strategies, and materials outside of the North American industrial sample library complex as a knowledge base to students, and then architects can be creative. And so your class, which is all examples and developing kind of taxonomies of different construction systems from Japan and around the world, and Otto Wagner, or whatever examples you use, or like Ed Ford's classic book, that stuff is critical because you're not going to figure that out by bending wire in a studio. You know what I mean? You need to combine the active kind of working with materials, maybe theme light, with here's a bunch of cool examples you'll never see that you're going to remember when you're designing a lab at Payette. You know what I mean? Like, I think that with the automation of everything, knowledge of examples becomes more important. So that wasn't a question, it was a manifesto.
Yeah, so let me give you can I give you a two-part answer? Can I give you a two-part answer to your question or your manifesto? First, I'll address the thematic nature. I chose the thematic nature of how to do it is because I'm an amateur when it comes to curriculum development and pedagogy. So I fell back on the thing that I know best. As an architect, because I practice in the field of science, I'm actually an experimentalist. The great tradition in science is that theorists sit around and think of things, and then they find experimentalists who build those things. Like a great example is the LIGO instrument, for instance. When I was at UChicago, Dr. Nambu won the Nobel Prize for the mathematics that created the LIGO project. He did the mathematics for the LIGO project in 1962 when he was like 30 years old. And they gave him his Nobel Prize when he was 87, because that's how long it took to prove, build, experiment, and run the LIGO project. So I in my career have become very much the experimentalist. So when I thought about the idea of what does this pedagogy look like? I mean, really, how do I teach this? I went immediately to what I know best, which is to experiment, right? I thought that the way to do this, the only way I was going to actually learn was to, see one, do one, make one, right? I had to get into it, and I had to learn what was relevant. I had to learn what was needed, and had to learn what really did resonate with the students. And so I think that the curriculum, for the most part, really is based on that thing. But it's also rooted in some proven things. Like I said, I use the example of the How to Make Anything class for the skills section, and the product design class at MIT for the design section. And so foundationally, it was kind of based on some known things. The thematic part of it was to try to focus the students on things that are relevant for what's ever happening today, or things that might be on their minds. So that's really the reason why it became that thematic thing. I'd like to address, though, your comment about building around the world. So I have built billions of dollars of buildings on 5 continents. I've built buildings in the Middle East. I've built them in Europe. I've built them in London. I've built them in Australia. I've built them in China. I've built them in Israel. I've built them in Mexico. I've built them in Canada. And I can tell you that there is no one system that is particularly better than another when it comes to the actual doing of things. You know, all of these systems tend to collide at some point between either being highly regulated, not regulated, you know, different kinds of labor markets, different kinds of skill sets. So there is no perfect way of doing it. There are things that some cultures are better at than others, right? When I first started working in China, it was a disaster. Whatever you drew, when they went and built it, it looked like a cartoon of the thing that you designed. I couldn't even believe what would go on. But the thing was, what you realize is that they're on the learning curve, right? So China has learned so well now that their construction industry easily rivals ours, and in some ways surpasses it. And in one of the places where it surpasses our industry is in the use of digital fabrication and assembly. When I was at HOK, we built an airport in Doha, and I went out to the site to visit it about halfway through construction, and we had designed this rather complex ceiling that was metal panels up above. And they had hired a Japanese contractor to come in and do it because they needed that level of precision. The contractor brought with him these walking spider robots. They were literally 8-legged machines with lifts on them that would walk around to a predetermined spot. And then they had a follow-on robot that would lift up the panels and hand it to the guys to put in. And each panel was barcoded in sequence. So the entire construction of the entire system of cladding that went on for almost 1.5 miles, right, was designed down to the level where they knew the sequence and installation of every single piece of it, right? It's only a matter of time before that level of technology is available to the guy with a pickup truck who builds your house. And that will be ubiquitous across international lines. That's why, you know, for me, that's why I have this concern in training the next generation of architects that they not be removed from making. And if the act of making is going to become something that's, you know, conceived of digitally, you know, fabricated by robots or fabricated remotely, that they have an intimate knowledge of what that stuff means, what that material does, right? So that they know if they're working on a project in Borneo and it's being fabricated by a Japanese contractor with Indian labor, that what they're sending to the site can actually be realized. Because that's where we're heading.
I did, because, well, I think it was a great response, Jeff, but I was curious also, Tim, about your point, unburdening making classes from a kind of thematic.
Sorry, Mark, can you use the mic?
Yeah.
I think it's hard.
Jeff, that was a great response, but I wanted to go back to Tim's prompt about unburdening making classes from theme. And I think that's an interesting premise, but it also brings with it a challenge, which is, in particular, how do you evaluate content? And I'm coming at this as a person who is hiring an increasing number of students who have some kind of making classes. How do I know which is good and which isn't? If it's a material exploration where you kind of figure it out as you go, one of the challenges there is you know, curation or metrics of success. And I'm not convinced that every class embeds that. I'm curious to know your approach.
Yeah. I would say two things to that. One is getting students to look at precedent. And maybe it's a little bit of a different kind of precedent in this particular case, you know, looking at applied research work that has very specific goals in mind. So we try and do that a lot. And the second piece is having them be really clear about articulating what it is that they're trying to do. So I found that there's sort of two types of students. There's the premeditated crime thinking, and then there's the crime of passion. And the crime of passion leads to like kind of interesting things, but maybe not always understanding what it's coming from. Whereas other students will work so hard to completely solve it in their head before they pick up anything, that's a problem too. So I think in either case, we try and get them to articulate the criteria that they're evaluating their work on and what it is that they're trying to do. So that tends to help us a lot.
And I think Yasmin also had it right in talking about constraints, because all of thematic approaches is giving the initial constraint.
Yeah, just to close my point about this, I think and I think this is what Rob is getting at, when the exploration results in, my favorite crime is when it's a crime of passion, and then you have an alibi. And I think, the way that I would put it is there's some R&D and messing around. I saw that in both of the photographs you had of the work. And halfway through that process, and I'm overly simplifying this, you take stock of the language that's emerging and the syntactical logic, and then you're intentional about that, and you actually made a system that's not just about the thing, but how the things fit together and become elements that work together in a more elaborated grammar, right? And that's how I would qualify. Typically, I'm on these kinds of reviews all the time. That's usually the project where a third thing has emerged, a grammar from scratch. And I think that's a process that's half playing around and then a kind of moment of realization of what you have and then capitalizing on it. And I think Yasmin talked about that in the HATS project, right? Where there's messing around and then it all coalesces for good projects. So just restating what Rob said.
So I was gonna bring you back to what you were mentioning about writing and the importance of writing. And I guess I related with AI in some fashion. Remember when I first came to the States, I wanted to be an architect and I knew I wanted to be an architect because I have previously studied in another country, but I was focusing on writing a lot. And every time I was gonna do a project, I would write about it. And that's how I was taught also in the Dominican Republic. You have to really write your thoughts. And I think that's a form of AI to some extent. And it's also like speaking out loud or looking at Tony Stark talking to his AI. It wasn't that the AI would resolve the problem. It was that it was gonna give you feedback and ask you the question back. So being able to get your thoughts on paper and read them back even out loud, you'll be like, no, I don't mean that. That's not what I mean. This is what I really mean. And reading it back, and I used to even thought about my projects with my girlfriend and tell her, like, what do you think about this or that? And it was that feedback. And what I want to say about that feedback is that feedback also, you could even find it, and maybe this is probably the first time you will hear this, with Louis Kahn saying, ask the brick, what do you want to be, brick? It's AI, it's asking yourself, what do you think I could be? What do you think I could do with that? And that same question could go with Carlos Carpa, with Stucco. It could go back with Frank Gehry and steel and metal. It could go back to that sort of tactile feedback. These guys haven't really worked with it the way that a craftsman, a laborer would work with it, but they would write and ask themselves, what do you think you could be? What do you want to be? What can I do with you? Right? And that curiosity, which is part of this process. And and necessity is not always there. But sometimes there's the necessity of just a desire, right? Like the Taj Mahal is not necessarily a necessity, like food and shelter. And most of the projects that we actually read on books don't really resolve any problem other than somebody's, I guess, love affair or desire to have this new home, or they're all in the books, but they don't really solve a necessity as the very basic water, shelter, food ones. But that sort of like, I guess, infatuation of human beings, right? So there's all of these other elements. And then I wanted to also talk about, we go back to the Bauhaus. I mean, the Bauhaus is probably to all of us the perfection of what is, I would say, I would love to go back to that school of what, there were materials making in a way that we don't see like almost anywhere. I think probably the citizen architect that we, you know, saw not kind of tried some new way of the Bauhaus with this building and building to the community and designing. But that also itself, you know, it was this constant feedback and picking up from all of these other elements, right? So and getting all of those pieces together. And that's one thing on the side. But I heard all of these comments, and he mentioned something also about picking winners. So that's something else. So one of these classes will be the good one. You know, I have to hire all these students. How do I pick winners? You know, and I go back to like people picking winners on the stock. You probably have a winner, and they will probably have the same luck as you. It's not even about the class. It's also about the effort and how consistent this kind of a student will be. It doesn't matter what class he was. There are winners everywhere. So I'm saying almost too bad. I'm sorry. You will probably not be able to pick a winner depending on the material that they're working with. That's really not how you're gonna pick a winner. There's probably other way of metrics of the winner. It's probably the ones that stuck the longest with whatever it is that they were doing. That will be the winner.
So you made a very good point about the conversational nature of design, right? And all of us who practice this on a daily basis know that design is a conversation. We either talk to ourselves by sketching on paper, we talk to each other, we collaborate with our engineers, we do all these things through conversation, and it's that conversation that many times drives ideas. But if you've ever read Negroponte's machine architecture machine, he starts off with a computer that he talks to. And the computer that he's talking to, he's describing to him, can you make an arch in the Palladian style? And the computer says, of course I can. Here's an arch in the Palladian style. Can you array that into a loggia? Oh, here you go, here's a loggia. In other words, when Negroponte was thinking about it, he was thinking about it more along the rules of Vitruvius or a pattern language, Alexander, or those sorts of things. But the reality of it is what AI will be able to do is going to be far more sophisticated in terms of what conversation means. If you've looked at any of the visual programs online that you describe AI and you have it draw a picture for you, and all it simply does is go out to the internet and find pictures of the things you're describing, and it just converges them together and melts them into something. But the images that it's putting forth are the machine's conception of what they think is appropriate for a human. And the machine knows nothing. It's not a human. It's never fallen in love. It's never written a song, right? So the thing is, if we don't have that kind of conversation, if we are headed to a future where we may have conversational AI that will help us design, we still need to know what we're making. We can't be divorced from the making of it. If you want to know how to pick the winners, I have no idea. I hire my students all the time. I think I've hired 3 of them this last semester. And you know, they come to the school now. I mean, just to make a pitch for Paul and Mass Art, our students just think differently. I don't know how else to describe it, but you know, they come to Mass Art with a lot of ideas and just a lot of creativity, and harnessing that and giving it some direction is a full-time job. I can tell you that. But our students do fantastic things. They go up and they do great stuff. So
We have
you know,
about 15 minutes left. So I know a few people had a couple questions, and then we can kind of move to wrapping up. Okay, yeah, so I have a question related to something Jeff said and something Rob said. And actually I have the same question for both of you. Rob talked about this idea of the different behaviors of the different material. Jeff talked about failing fast, which I thought was a really interesting idea. And so I'm curious about, like, do you establish criteria? Do you establish broad criteria? Or what, you know, like, how do you decide what's failed, right? Or is it like something that is part of the discovery? Thank you.
the students are the ones who define the criteria. So whether they meet their own criteria or not is really self-evident. But we want them to fail faster because we're prototyping for a living, right? Don't tell me you have an idea. Go build the idea and come back and show it to me. Then we can talk about it.
I would agree with that. I think part of the problem for the students is to develop the criteria. It's most cases unique to their particular problem they're trying to solve. But we can always fall back on very clear performative criteria, so is it intended to shade from the sun in a particular way at a particular time of day and so on. So there's always those really important aspects of performance that we can point to in a very direct way architecturally. That's what I try and focus on.
Yeah, I sort of had one sort of question. For me, I'm really interested in what you're seeing as sort of the innovation of drawing as a result of this. As someone who most recently has been really diving into more design build, it's been a real kind of like revelation in my career to think about, yeah, I love to make and I like to explore, but how do I now innovate the drawings to kind of explain the act of exploring and making? And that's been such a great sort of like way of exploring this idea of materials and making, but how do your drawings start to evolve because of this active making? I was sort of really interested by some of the examples you showed, and I really want to talk a little bit about the sort of evolution, innovation of architectural representation as a result of this exploration.
No, I love the question because I think it's something I'm very curious about too, especially since we spend a lot of time drawing as architects. And I think there's simple things, right? Just kind of thinking about the kind of conventions of architectural drawing. What happens when we kind of acknowledge, let's say, material differences. So, typically architectural drawings are black and white for a whole host of reasons, but if you actually start to kind of give a color to every single material in an assembly, it's actually, you can track things in a very different way than maybe a black and white drawing that's purely about kind of geometrical relationships or volumetric relationships. So I think that I think conventions are incredibly useful because they allow us to kind of communicate with a group of people that are also familiar with the conventions, but I think there's small tweaks and that kind of start to allow you to ask different questions and start to kind of raise them to the surface in drawings like that I think are really effective.
Just to add to that, I think there's so much potential with time-based documentation, especially around ideas of performance and material characteristics or behaviors. I mean, behaviors are a hard thing to draw, but I think it's a really great challenge. But I do try and rely a lot on time-based ways of capturing things too.
You both think drawing is about communication. Right, either with yourself or with others. So how you do that matters to what you're trying to do. Like, it's not an accident, I think, that all of you show the work in a studio culture, where the place of respect and trust is not built on the first day. It's built amongst the culture that you've created. And then the exchange happens or the creativity happens. And I think that drawing is communication is really essential. And, I always listen to Tim because he's a smart guy. And he talked about grammar. You use the word grammar. And I think that's really essential about what you're talking about because it's not the poetry, right? That may or may not happen with the student. And it actually isn't the winner. You want somebody who understands the grammar so that they can be useful and productive with a tool or a way to communicate. And then I think, for me at least, the poetry will happen when it does, right? But we're architects, so you can't sit and wait for inspiration. You have to work. There is no blank slate. There is no empty canvas. It's your process, it's your tools, it's your material. So I think grammar is the right, for me at least, is the right term. It's like the prose, right? It's how you make something. You need to understand the craft of that. And I think that's something that I really heard in the answer you just gave.
So we have probably time for
I just want to say,
what started out as a question is going to end up as a comment. And this has been such a great conversation. I did not realize we were going to be so squarely centered on pedagogy and talking about teaching, and the conversations here have just been, mind-boggling. These are things that I think about a lot, but I have not heard such a richness of ideas centered on the things that so much affect our curriculum on a day-to-day basis. I think the observation I want to make is that we have focused a lot on individual classes or studios as laboratories, sort of standalone laboratories. I think the real challenge is constructing a full curriculum where the objectives, the challenges start at one level for the entry-level students, and then we're hoping to get these very, very exciting, advanced experimental approaches. Those aren't the first courses that students find, but they have to develop an openness and a receptivity and a curiosity through the earlier courses. And those earlier courses are the petting zoos, the feel the clay, and it's not, I don't mean that in any kind of condescending way. I think it's the same as children learning how to play a scale on a piano. It's grammar, it is those building blocks. And there's a way that the mind is developing through those exercises that is fundamental to any kind of advanced research that's going to happen. So I personally have found at Wentworth and previously at the GSD, like trying to make a whole out of a technology curriculum. The challenge is the connectivity and the talking between parts and the setting of each next level of expectation in terms of the challenges the students are able to engage in their curiosity and where they will drive this. It's not all faculty driven. It is, we have to prepare those excellent students that will challenge the student, challenge the instructors just as much as it works the other way. It's a comment and not a question, but I think maybe it will prompt some response from Rob.
Yeah, I was going to say, I think the synthesis across courses and across years is really hard for students and for faculty, I think. So, I don't know how many times NJ and I have talked about, well, didn't you tell your students about X, Y, and Z? And then, they think they're hearing it for the first time. But making those connections, making them rich enough for the students to engage in, I think is super challenging. But as you said, it's thinking about it as through the entire curriculum, and to the point about the first year students learning something and then testing it later, there's a good chance that students may not take a course with me and do something that I'm doing. They might be doing something completely different at their urban scale. So, but how you address it at a foundational level is very different, but important in comparison to the more advanced work.
This is why I start with the idea of the Bauhaus. We need a curriculum that addresses the German Industries 4.0 model, as opposed to the Bauhaus model, because the 4.0 model is the way out, is the way things will be produced in most of the world.
All right, so I guess it's ideal that I'm gonna wrap it up with my last comment, and it is that with the fact that I'm hanging out with my architect's licensing here, there's just so much we can do at school. There's just so much we can actually get people into. But at the end of the day, I guess this country cares about the health, safety, and welfare of the public. So at the end of the day, we're raising architects, right? Whichever type of architect that we think that we want to raise, but they're all going to go out there and make a world in some fashion. I think that it's not about picking winners, it's actually about making winners. And that's one thing that my company, Flow Design Architects, does. We pick all these people that wouldn't really find themselves into the profession and become the best that they could possibly be and bring their own biases and ideas and culture into design. Education doesn't end at school, and we know that. In fact, every day I feel like I'm an architect more than the previous day. And then sometimes I'm like, no, I'm just in marketing. No, I'm just writing proposals. But the thing is that every day we really realize that we are a different kind of architect and that we are becoming more of an architect in some fashion. And school is not gonna cut it, it's not gonna do all of it. In fact, they come to us with a lot of voice. And we have our own program and our own YouTube channel. And we're like an educational center And it pays off over time. Unfortunately, some of them move and quit and go somewhere else, but eventually they become the stars that are really profitable and help us make a better world at the end of the day.
That's a perfect
Thank you.
final.
Yeah,
Yeah.
that's perfect.
Perfect timing. Well, thank you again to our guests. Thank you, Jeffrey, for coming online with us. Rob, Yasmin, thank you so much. This has been great. Thank you to the audience. There's a few peanut butter pretzels left.
Yeah. Well, the cheese,
Thank you.
yeah, please.